you have this slide in your notes, but this is straight out of your textbook, and I did want to talk about it. So far what we've done is we've done factoring, which is no different than what you did in grade 10. It just might be a little bit harder factoring because we have the fractions and stuff like that. But the whole point of this chapter is to come up with ways to find our x-intercepts from our graphs, right? Okay, so in 4.1, we found our x-intercepts by using your calculator. In 4.2, we're obviously going to be using factoring, but we haven't made that connection yet. Okay, so I'm just going to read through this and we'll make the connection of how this factoring can help us out. So, some quadratic equations that have real number solutions can be factored easily. The zero product property states that if the product of two real numbers is zero, then one or both of the numbers must be zero. So this means if you have something like d times e equals 0, at least one of d or e is 0. They could both be 0, or if d is 0, I don't care what e is, or if e is 0, I don't care what d is, okay? So the roots of a quadratic equation occur when the product of the factors is equal to 0. So to solve a quadratic equation of the form ax squared plus bx plus c equals 0, okay, the a can't be 0 or you don't have a quadratic, right? You would factor the expression and then set each factor equal to 0, and the solution should be the roots of the equation, or in other words, the x-intercepts of your graph. So here's an example here. They said, rewrite this quadratic equation, 3x squared minus 2x minus 5 equals 0 in factored form. Now, they skipped all their steps here, but they did end up with this factored form. So you would be able to go from this quadratic to this factored form. And if the quadratic was equal to 0, now you can set the factors, the multiplication of the factors equal to 0. And this is like that d and that e they were talking about. If this sum factor times by sum factor equals 0, then either this factor is equal to 0, which means my x would have been 5/3, or this factor is equal to 0, or my x is negative 1. And those are going to be my x-intercepts. Now, how did they get through that? All they did was they set my factor here, 3x minus 5 equal to 0, and then they solved for x. So they skipped some steps here. How would you solve for x here? How do you get x by itself? Yeah, go ahead. You would add your 5 over to the other side, and then you would divide by 3. Okay, so that's where they're getting 5/3. Okay, now, almost all of your factors will be of that form. I'm just going to put ax plus b of some form like that, right? They might have a number in front, they might not. But basically, when you set them equal to 0, it will always be the opposite of this gets added or subtracted over to the other side, and then you would divide by the other item. So it's always going to work like that. Okay, so if your factor was 2x plus 1 equals 0, it would be a negative 1, because it would have to subtract over to the other side, and then you would divide by 2. So your x could be a negative 1/2. So if you choose to skip those steps, that's okay. If you're somebody that's like, whoa, I'm not ready to skip those steps, you go ahead, you minus your 1 from both sides, you rewrite it, you divide by 2 on both sides, and then there's one of your answers. So that's an example of how you can show your work if you need to. Okay? We do want 2 answers if we can, because if there's 2 factors, that means there was 2 x-intercepts, which makes sense because quadratics can have 2 x-intercepts.